So in this lesson, we're going to start to look at actual data that's collected from a sample. It says, last lesson you learned that data is often collected from a sample of the population of interest. Assuming that the sample is chosen randomly, the data from the sample is supposed to represent the population from which it was chosen. The first step in the process of using data is organizing that data and making measurements of center, which are mean, median, or mode, and spread, range, interquartile range, and standard deviation. For this course, we are most interested in just finding the mean or average and the standard deviation of the data set. The calculator will take care of most of that for us, and then we'll just be processing the data. So the first exercise says, to report the highway gas mileage for the 2018 Dodge Ram, the company randomly selected a sample of cars and tested them. So they're not going to go out and test every single Dodge Ram, but they collected a random sample. And the first thing we want to do is organize our data into a frequency table. So represented in this data, we see these different mileages, which if we didn't have this, we would list it ourselves. And we're basically going to count and see how many of each number is. Now I'm going to start the process, but then I will ultimately just write what's there so we don't have to make the video too long. So I have a 23, I have two 27s and a 28. And if I continued this process, I would end up with 1 23, 3 24s, 5 25s, 7 26s, 5 27s, 2 28s, and 2 29s for a total of 25. When you get your total, it's always a good idea to go back and count the values to make sure you didn't miss anything. So the mean of the distribution is interpreted as a typical value and is the average of the data values that make up the distribution. So it's one number to kind of represent all the numbers. The standard deviation is a value that describes a typical distance from the mean. So about, on average, how far is each data value away from that center mean? We're going to be using our calculator's one variable stats command to find the mean and standard deviation of the mileage data. Directions are here, and I'm going to be pulling up the calculator. So here is the calculator. If you look at the directions, just like when we did regressions, this is statistics or data to enter in, so we press the stat button, and then we're going to choose number 1 edit. Now, if there's any information in my list, just as a reminder, I'd put my cursor on L1 and press clear, enter, not delete. We don't have any data, so in the first column, we're going to enter the mileages. So the 23, 24, 25, and just continue entering those numbers. So we have straight numbers from 23 to 29. And in the second column, we're going to enter our frequencies. So I have 123, I have 3 24s, 5, 7, 5, 2, and 2. I definitely check to make sure there's the same number of things in each list, which there should be. So now in those steps, I did stat, number 1 edit, I entered the 2 lists in L1 and L2. Now I'm going to press stat again. Go over to calc. So we have been using linear regression and exponential regression. Here we're just going to be using the first thing, which is one variable stats. So choose 1. Now it's a little different here. My list is L1. I'm going to scroll down. I have to say there's a frequency list. So that was the information in L2. So I press second, and then L2 is right on the number 2. So second L2. Yeah, so before, when we did regression, you could just enter through the menu. You have to make sure you have list 1 and list 2 there. Go down to calculate and press enter. So for this information, the 2 pieces of information I need are the mean, which is represented by the X with the bar. And then this is a sample. The SX stands for the sample standard deviation. So that's the information that I'm going to be writing down on the page. So going back over to the lesson and scrolling down just a little bit. We used our calculator's one variable stats command to find the mean and to the nearest hundredth. that is 26.04, and the standard deviation is 1.54. So average value for these mileages is 26.04, and on average, each one is about 1.54 from that number, each data value. Some are further, some are closer. So now we're gonna put the data into the two types of graphs that we'll use this unit. One is a dot plot. I'm gonna zoom a little bit differently here. Nope. It's different than my computer. Okay, so when I do the dot plot, I'm using that data. So it's gonna be hard to completely get both of them. I'll move this up here. So there is 123. Okay, there are 3 24s. There are 5 25s. And to the best of my ability, it doesn't have to be perfect, but try to kind of make that even across. 7 26s. It's not totally even. And 5 27s. And then 2 of each of the 20 and the 29. So that's a dot plot. It gives me an idea of the shape of the data. What does it look like in the graph? A histogram is very similar, except we make bars that touch. So the dot plot is a little bit simpler than the histogram. So for the histogram, I'm going to make a bar 23, 24, 25, and 26. So I kind of pick a width. 2 worked well to kind of fill in the graph. And then up the side, I'm going to also go every 2 spaces is 1. So 1, 2, 3, 4. And you probably would need to take a little more time to count. I already had this done before, so I knew how high to go. So there is 1 23, 3 24s. And this is, as I said, a histogram, not a bar graph. So we make the bars touch on a histogram because the values lead into each other. We're assuming like 23 is anything that rounds to 23, and then right next to it is anything that rounds to 24, and so on. So this bar is 7, and then we've got another 5, and a 2, and a 2. So one of the things we talk about in graphs is symmetry. This isn't perfectly symmetric, but it's pretty close, okay? Other than like kind of these two have different sizes than those two, it's pretty symmetric. So there's a couple questions about our graphs on the next page. We're just gonna go over there and look at them. It says, describe the shape of the mileage distribution. On the histogram, draw a smooth curve that comes reasonably close to passing through the midpoints of the tops of the bars. Describe the shape of the curve. So we're actually going to do the drawing part first. So we're going to draw a smooth curve that connects the midpoints of the tops of the bars. So we're trying to make it not just like choppy. So it's kind of like that. So when we see that type of shape, we can call it mound shaped. We'll have some other names for it as we go through the unit. But for now, it looks like a mound. Most is in the middle, less and less on the sides. So the next task with this, we're going to mark the mean on the histogram and mark 1 standard deviation to the left and right of the mean. Shade the area under the curve that represents the proportion of data, or the proportion is like percentage kind of, right? Like what proportion, like probability, that are within 1 standard deviation of the mean. Estimate the percentage of the curve that you shaded in. So over here, at the bottom, our mean is 26.04. So here's my bar for 26, and 26.04 is kind of like right here, like almost on the 26 line. So that's my mean, okay? I'm going to write that there. I'm also going to write the 26.04 next to it. If I had more room below it, I would write it there. And then we're going to go 1 standard deviation to each side. So I'm going to show that work here, even though it goes with that previous question. So my mean is 26.04. If I want to go 1 standard deviation above, I would add the 1.54. So that number is going to give me 27.58. So I'm gonna go to here, we're kind of at 27.58. This is really like 26.5, that's 27.5, so that's right here, kind of heading to the middle, that's 28. So this is 27.58, and I'm also gonna write that's when I added 1 standard deviation. So in the other direction, if I subtract 1 standard deviation, we're trying to go in both directions according to the question. That's gonna give me a value of 24.5. So 24.5 is right here. Okay, so that's, I did a -1, and that's 24.5. So that's going 1 standard deviation in each direction. Now my next direction is to shade in that area. So I have that curve. Oops, I went too far. Okay. Pretend I did not go over there. Erasing is always difficult because then you end up erasing too much, but we'll fill in the rest of it. And it will be fine. Okay. So now looking at that green shade, out of the whole area of that, how much do I think I shaded it? Okay. So I would like you to pick a number on your own, okay? Estimating, I don't know, 60%, 70%, maybe something like that. If we want to actually count the amount in each of the bars, we can do that too. So for the shaded region, I have 5 in this bar, I have 7 in this bar, and I have 5 in this bar. We have like a smidgen of that other bar there, but it's pretty much these 3 numbers. So if we want to calculate this, we're doing 5 plus 7 plus 5 out of the total 25. And that actually comes out to 17 out of 25.68. So about 68% of the data fell within 1 standard deviation. That's deviation of the mean. And just to have the notes over here, the way we calculated that, we took the mean and we added 1 standard deviation, and the mean and we subtracted 1 standard deviation. So we had this on the other page, but just to have it here for your notes, we got 27.58 on the high end and 24.5 on the low